September 2nd, 1859, 5 a.m., Havana, Cuba. A telegraph operator named Jose is half asleep at his desk, waiting for the morning's first messages. Outside, it's still dark. The tropical air is thick with humidity. Nothing unusual. Then the room explodes in sparks. Telegraph wires spontaneously combust. Sparks shoot from the equipment, setting papers on fire. Jose jumps back as his telegraph key becomes too hot to touch. The entire telegraph network, the Victorian Internet, is being electrocuted by an invisible force. Jose runs outside and stops dead. The sky is on fire. Green and red curtains of light dance overhead. In Cuba, the aurora borealis, which shouldn't be visible south of Canada, is painting the Caribbean sky like a cosmic acid trip. In the Rocky Mountains, gold miners wake up at 1 a.m. thinking it's dawn. They start making breakfast. Birds begin singing. The light is bright enough to read a newspaper, except it's the middle of the night, and the light is green. In Boston, telegraph operators disconnect their batteries completely and discover they can still send messages. The lines are so charged with atmospheric electricity that the telegraphs are running on angry sky power alone. In London, The Times reports, the whole of the northern horizon was in a livid red flame. It seemed as if the world was on fire. This was the Carrington Event, the most powerful geomagnetic storm in recorded history, a solar temper tantrum that turned Earth's magnetic field into a cosmic punching bag. In 1859, it burned some telegraph wires and gave people a cool light show. If it happened today, it would end civilization as we know it. No power grid, no internet, no satellites, no GPS, no communications, no banking, no supply chains, no refrigeration, no modern life. Just billions of people suddenly thrown back to the Stone Age with no warning and no way to fix it. And here's the fun part. It's not a matter of if this will happen again, it's when. The sun does this regularly. We just happened to invent civilization during a quiet period. We built a technology-dependent society on a planet that gets periodically punched by its own star. Tonight, we're going to explore the day the sun tried to kill us, almost succeeded, and promises to try again soon.
Welcome, my electromagnetically vulnerable friends, to minutes of cosmic horror that's not fiction, not distant, and not avoidable. Get comfortable, but not near any electronics, because after you learn what the sun can do, you'll never trust electricity again. Let's start with an uncomfortable truth. The sun hates you. Okay, that's not fair. The sun doesn't know you exist. It's a massive ball of nuclear fusion that's been exploding for 4.6 billion years. You're a briefly animated collection of carbon on a speck of dust 93 million miles away. The sun doesn't hate you any more than a flamethrower hates an ant, but the effect is the same. The nuclear monster next door. The sun, Earth's abusive parent. Mass, 333 times Earth. Temperature, core, 27 million degrees Fahrenheit. Surface, 10,000 degrees Fahrenheit. Power output, 384.6 trillion watts. Magnetic field, complex, twisted, and psychotic. Mood, violently unpredictable. Every second, the sun converts 600 million tons of hydrogen into helium through nuclear fusion. The missing mass becomes energy that eventually reaches Earth as sunlight, warmth, and occasionally civilization-ending electromagnetic storms. Thanks, sun. Really appreciate the mixed signals. The sun's bipolar disorder. The sun has an 11-year cycle where it goes from relatively calm to absolutely insane and back. We call this the solar cycle, which sounds scientific and controlled. It's not. It's the sun having mood swings that could kill us. Solar minimum. The sun is calm, still exploding, just less. Solar maximum. The sun is angry and throws tantrums. Sunspots. Dark regions that are actually 6,000 degrees Fahrenheit, but look dark because everything around them is 10,000 degrees Fahrenheit. Solar flares. The sun's middle finger to the solar system. Coronal mass ejections. The sun literally throws pieces of itself at planets. Every 11 years, the sun's magnetic field completely flips. North becomes south, south becomes north. Imagine if Earth did that. Your compass would be useless. Birds would fly into buildings. GPS would have an existential crisis. Actually, that's basically what happens when solar storms hit us. Enter Richard Carrington, the man who saw the sun attack. Richard Christopher Carrington was a British amateur astronomer. Amateur meaning he was rich enough to not need a job and spent his time staring at the sun through telescopes, as one does. Carrington's resume: brewery heir, explained the free time, built personal observatory, obsessed with sunspots, meticulous record keeper, first to witness a solar flare, immediately knew Earth was screwed. On September 1st, 1859, Carrington was doing his usual sun stalking when he saw something unprecedented, a massive explosion on the sun's surface. Two kidney-shaped white light flares appeared over a sunspot group, intensely bright even against the sun's surface. Carrington later wrote, "I witnessed a singular appearance, which I hastened at once to secure as far practicable by sketch." Translation: "Holy shit, the sun just exploded. I better draw this." He ran to find a witness, but by the time he returned with someone, the flare was fading. Those 5 minutes would change our understanding of the sun forever. Carrington had just witnessed the first recorded solar flare. What he didn't know was that this flare had launched a coronal mass ejection, basically a solar bullet, directly at Earth. Travel time, 17 hours and 40 minutes.
To understand the Carrington event, we need to understand what the sun actually did to us. This wasn't just one attack. It was a coordinated assault. The sun hit Earth with a 1-2-3 punch that would make Mike Tyson jealous. Punch 1. The solar flare, September 1st, 11:18 a.m. A solar flare is when magnetic field lines on the sun get so twisted they snap like rubber bands, releasing energy equivalent to 1 billion hydrogen bombs. The Carrington flare. Energy released, 10 to the 25 joules. Temperature, millions of degrees. Speed of light, 8 minutes to Earth. Effect, X-rays and UV radiation hit Earth's upper atmosphere. 8 minutes after Carrington saw the flare, Earth's ionosphere was being cooked by X-rays. Radio operators, if they'd existed, would have experienced complete blackout. But in 1859, the most advanced communication was the telegraph. The telegraphs just got weird. Punch 2. The coronal mass ejection. When the sun has a solar flare, it often follows up by literally throwing part of itself at us. This is a coronal mass ejection, billions of tons of magnetized plasma traveling at millions of miles per hour. The Carrington coronal mass ejection. Mass ejected, 10 billion tons of plasma. Speed, 2,000 kilometers per second. Normal is 400 kilometers per second. Travel time to Earth, 17.6 hours. Usually takes 3 to 4 days. Kinetic energy, enough to power the US for 1 million years. The sun basically spat at Earth, except the spit was superheated plasma carrying a magnetic field 50 times stronger than normal. It crossed 93 million miles in less than 18 hours. That's like throwing a baseball from New York to Los Angeles in 0.001 seconds. Punch 3. Geomagnetic chaos. When the CME hit Earth's magnetosphere on September 2nd, all hell broke loose. Earth's magnetic field, which normally looks like a nice neat dipole, got compressed, twisted, and partially torn open. Imagine a soap bubble being hit by a fire hose. That's Earth's magnetosphere during the Carrington event. What happened to Earth's magnetic field? Compressed from 65,000 kilometers to 7,000 kilometers on the day side.
Night side stretched over 6 million kilometers. Magnetic field strength fluctuated by 1600 nanoteslas. Induced electrical currents in everything conductive. Aurora visible at the equator. The aurora being visible in Cuba, Hawaii, and Colombia would be like seeing polar bears in the Amazon. It's not just unusual, it's the physics of Earth are broken unusual. The Victorian internet dies. The telegraph system in 1859 was humanity's first global electronic network. Messages could cross continents in minutes instead of months. It was revolutionary. It was also made of long copper wires that acted like antennas for geomagnetic storms. What happened to the telegraphs? Wires became spontaneously electrified. Operators received electric shocks. The telegraph paper caught fire. Systems operated without batteries. Some telegraph offices burned down. Think about that. The telegraphs worked better without their power sources. The atmosphere was so electrically charged that it was providing more power than the batteries. It's like unplugging your phone and having it charge faster from angry air. First-hand accounts from the electromagnetic apocalypse. Let me read you some actual accounts from telegraph operators who lived through this. These aren't dramatizations, these are real reports from people who thought the world was ending. Frederick Royce, Washington, D.C. Telegraph Office. The electromagnetic current was so strong that we could work the line between Washington and Baltimore without batteries. On disconnecting the batteries, the line worked better than with them connected. Who needs coal when the sky is angry enough to power our machines? Frank Smith, Boston Telegraph Office. I received a severe electric shock from my equipment. The shock was strong enough to knock me from my chair. When I recovered, the paper tape was on fire. The entire office smelled of burning copper and ozone. Imagine going to work and your keyboard electrocutes you, then sets itself on fire, then continues typing by itself using atmospheric rage. That's a bad day at the office. That's a maybe I should have been a farmer kind of day. The light show that broke physics. The aurora during the Carrington Event wasn't just visible in weird places, it was bright. Catastrophically bright. Contemporary reports. New York Times. The light was so brilliant that at 1 o'clock in the morning print could be read as easily as at midday. Rocky Mountain News. The auroral display was witnessed by thousands, many of whom were awakened from sleep by the brightness. Australian gold miners. The southern aurora was blood red and bright enough to read newspapers at midnight. People in the Caribbean saw aurora. People in Hawaii saw aurora. The aurora was visible from the poles to the equator. That's not supposed to happen. That's like snow in the Sahara, except the snow is made of electromagnetic death. The nautical nightmare. Ships at sea had their own problems. Ships' compass chaos. Compasses spun wildly or pointed in wrong directions. Navigation became impossible. Several ships ran aground. Maritime chronometers failed. Sailors reported St. Elmo's fire on every metal surface. Captain Charles David of the bark, Southern Cross. The compass needle swung through a complete circle repeatedly. The sea itself seemed to glow with a greenish light. Metal fittings sparked when touched. Several crew members refused to work, believing the ship was cursed. Imagine being on a wooden ship in the middle of the ocean when every piece of metal becomes electrified and your only means of navigation decides to have a seizure. Oh, and the sky is on fire. And the ocean is glowing. Totally normal sailing weather. The underground effects. Even miners underground weren't safe. Colorado mining reports. Underground telegraph lines sparked in mines. Miners reported shocks from metal tools. Some claimed to see glowing ore veins. Canary birds, used to detect gas, died mysteriously. Several mines evacuated fearing supernatural events. The electromagnetic storm was so powerful that it induced currents in ore deposits underground. The Earth itself became a conductor. The planet was literally electrified from the inside out.
Now that we've covered what happened, let's talk about how it happened. Because understanding the mechanism is the difference between, wow, that was weird, and, oh God, this could destroy everything we've built. Solar Weather 101. How the sun attacks. The sun doesn't just shine light at us, it's constantly throwing stuff. The solar wind, a constant stream of charged particles. Speed, 400 to 800 kilometers per second normally. Density, 5 particles per cubic centimeter. Temperature, 1 million degrees. Earth's magnetosphere usually deflects it. The solar wind is like the sun's passive-aggressive baseline hostility. It's always there, always pushing, always trying to strip away our atmosphere. Earth's magnetic field is the bouncer keeping this riffraff out. Usually. Solar flares, when magnetic fields snap. Solar flares happen when the sun's magnetic field gets twisted up like headphone cables in your pocket, then suddenly untangles with explosive force. The process? Magnetic field lines emerge from the sun, differential rotation twists them, energy builds up over days or weeks, critical point reached, snap, magnetic reconnection, energy released as radiation across all wavelengths. The Carrington flare released energy equivalent to 10 billion Hiroshima bombs per second for 5 minutes. That's 3 trillion Hiroshima bombs total. The sun looked at Earth and decided to demonstrate what nuclear warfare looks like when you're a star. Coronal mass ejections, solar bullets. A CME is when the sun literally ejects part of its corona into space. It's not just energy, it's actual solar material. What's in a CME? Plasma, superheated ionized gas, magnetic field, frozen into the plasma, speed, 250 to 3,000 kilometers per second, mass 1 to 10 billion tons typically, width can be wider than the sun itself. The Carrington CME was special. It traveled at 2,000 kilometers per second, 5 times faster than average. Why? Because another CME had cleared the path a day earlier. The first CME was the snowplow, the second was the NASCAR driver drafting behind it. Earth's magnetosphere, our only defense. Earth's magnetosphere is generated by our molten iron core. It's basically a force field that deflects solar particles, usually. Normal magnetosphere extends 65,000 kilometers on the day side, stretches 6 million kilometers on the night side, deflects 99.9% of solar particles, creates the Van Allen radiation belts, and channels particles to the poles, creating normal aurora. During the Carrington event, it was compressed to 7,000 kilometers on day side, magnetic field lines broke and reconnected, solar particles penetrated to lower altitudes, induced currents at ground level, aurora at the equator. Earth's magnetosphere during Carrington was like an umbrella in a hurricane. Technically still there, technically still deflecting some rain, but you're still getting soaked, blown away, and possibly impaled by debris. Faraday's nightmare, how space weather creates ground currents. Here's the part that should terrify anyone living in the modern world. Geomagnetically induced currents. When the magnetosphere changes rapidly, it induces electric currents in any conductor on Earth's surface. Telegraph wires in 1859, power lines today, pipelines, railroad tracks, cable internet lines, basically all modern infrastructure. Faraday's law of electromagnetic induction states that a changing magnetic field creates an electric field. The Carrington event changed Earth's magnetic field so violently that it turned the entire planet into a generator. Every long conductor became a wire in Earth's planetary dynamo. The terrifying math. Let's do some quick calculations. 1859 telegraph network. Total wire length, approximately 200,000 kilometers. Voltage induced, 100 to 1,000 volts. Current, several amperes. Result, fires, shocks, equipment damage. Modern power grid. Total wire length, approximately 6 million kilometers US alone. Voltage potential, 10,000 plus volts. Current potential, thousands of amperes. Result, complete grid collapse. We've basically wrapped the entire planet in conductor wire and then act surprised when solar storms induce currents. It's like covering yourself in aluminum foil and standing in a thunderstorm. What could possibly go wrong? Here's something fun. The Carrington event wasn't a once-in-a-millennium freak accident. The sun has tried to Carrington us multiple times since 1859. We've just been lucky. Stupidly, ridiculously lucky. The 1921 New York Railroad Storm. May 15th, 1921, a solar storm 1/3 as powerful as Carrington hits Earth. What happened? New York Central Railroad Control Tower destroyed by fire. Telegraph operations worldwide disrupted. Telephone and telegraph cables under the Atlantic failed. Aurora visible in Los Angeles and Atlanta. Several buildings burned from electrical fires. If the 1921 storm happened today, estimated damage $2 trillion. That's trillion with a T. That's more than the GDP of Russia from one solar storm. The Halloween storms, modern Carrington light. October-November 2003, the sun decided Halloween needed real scares. The damage? Swedish power grid partially failed. 50,000 people lost power. 12 satellites damaged. 1 totally lost. ISS astronauts took shelter from radiation. Aircraft rerouted from polar routes. GPS accuracy degraded worldwide. Japanese satellite ADOS-2 killed. This was a relatively minor storm. It only caused $10 billion in damage, killed a few satellites, and forced astronauts to hide from space radiation. Barely worth mentioning, really. The Quebec Event, when Canada went dark. March 13th, 1989, a solar storm 1/10 as powerful as Carrington. The timeline of disaster. 2:44 a.m., geomagnetic storm begins. 2:45 a.m., voltage fluctuations on the Quebec grid. 2:46 a.m., protective relays start tripping. 2:47 a.m., cascading failure begins. 2:48 a.m., entire Quebec grid collapses. 2:49 a.m., 6 million people in darkness. 92 seconds. That's how long it took for a minor solar storm to black out an entire province. The grid collapse was so fast that operators couldn't respond. By the time they understood what was happening, it was over. The aftermath? 9 hours without power for millions. Montreal Metro shut down during the morning rush. Dorval Airport closed. Electric heating failed in minus 15 degrees Celsius weather. Total damage? $2 billion. July 23rd, 2012. The bullet we dodged. This is the one that should keep you up at night. On July 23rd, 2012, the sun fired a Carrington-class CME directly along Earth's orbital path. It was as powerful as the 1859 event, maybe stronger. It missed Earth by 9 days. 9 days. The details? CME speed, 3,000 kilometers per second, faster than Carrington. Arrival time would have been 15 hours. Magnetic field strength, 50 plus nanoteslas. If it had hit, global technological collapse. Dr. Pete Riley, Predictive Science, Inc. If it had hit, we would still be picking up the pieces. The July 2012 storm was at least as strong as Carrington. The only difference is it went in a different direction. We missed a civilization-ending event by 9 days because Earth happened to be on the other side of its orbit. It's like dodging a bullet because you bent down to tie your shoe, except the bullet was the size of a planet and made of magnetized plasma. The statistics that should terrify you. Probability of Carrington-class events. Next 10 years, 12%. Next 50 years, 40 to 60%. Next 100 years, 85 to 95%. Next 200 years, 99.9%. Those aren't probabilities of maybe the power flickers. Those are probabilities of civilization grinds to a halt and millions die. Pete Riley's peer-reviewed paper puts the probability at 12% per decade. That's worse odds than Russian roulette. The exoplanet perspective. Here's a thought that'll mess with you. Every star does this. Every planet with technology eventually faces this problem. The Drake equation modification?
Maybe the reason we don't see alien civilizations isn't because they don't exist. Maybe it's because they all reached our level of technology, got dependent on electronics, then got Carringtoned back to the Stone Age. It's cosmic natural selection against technology.
All right, let's stop dancing around it. Let's talk about what happens when, not if, when a Carrington-class event hits modern Earth. Buckle up, this is going to be darker than a post-Carrington city at night. Minute 0, the flare. The sun releases a massive flare. We have 8 minutes before the radiation arrives, but we won't know it's coming until it hits. First wave impact, 8 minutes. Radio communications, dead. GPS satellites, confused or dead. Aviation, all flights grounded immediately. Astronauts on ISS, radiation shelter protocol. Satellite TV, gone. Cell towers using satellite backhaul, offline. 8 minutes after the flare, anyone trying to use GPS navigation drives into a lake. Your smart TV becomes a dumb mirror. The ISS crew is huddled in the most shielded part of the station, hoping their DNA doesn't get too scrambled. Hours 8 to 20, the calm before the storm. We know the CME is coming. We have maybe 15 or 20 hours. This is humanity's last chance to prepare. What actually happens? Governments issue warnings that most ignore. Power companies attempt controlled shutdowns, mostly fail. Hospitals switch to backup power, for now. People panic buy everything, creating immediate crisis. Financial markets crash, electronic trading halts. Social media spreads misinformation faster than facts. You'd think 15 hours warning would help. It doesn't. It's enough time to know you're screwed, but not enough time to do anything about it. It's like watching a slow-motion car crash while being strapped to the hood. Hour 20. Impact. The CME hits. Earth's magnetosphere collapses like a tent in a hurricane. Immediate effects. Power grids worldwide, cascading failures begin. Transformers exploding or melting. Pipelines corroding from induced currents. Internet backbone. Major cable failures. Satellites, 40% immediately dead, rest dying. Aurora, visible at the equator. The power doesn't just go out, it dies violently. Transformers don't just fail, they explode. Some catch fire. The lucky ones just melt internally. The unlucky ones take out entire substations. Day 1. Welcome to the new Stone Age. What's dead? Electric grid, completely. Internet, completely. Cell phones, no towers, no power. Water pumps, no power. Fuel pumps, no power. Refrigeration, no power. Banking, no power, no internet. Supply chains, no communication, no fuel. Modern vehicles, fried electronics. Your car might not start. Modern cars have 100+ microprocessors that just got fried. Your phone is a paperweight. Your credit cards are useless plastic. Cash is king, except ATMs don't work and banks can't open their vaults because they're electronically locked. Week 1, the unraveling. Days 1 to 3. Urban water systems fail. Sewage backs up. Food and refrigerators spoils. Medications requiring refrigeration lost. Fuel runs out. No pumps working. Government continuity plans activate poorly. Days 4 to 7. Hospitals lose backup power. Dialysis patients start dying. Insulin-dependent diabetics in crisis. Civil unrest begins. Military deployed to maintain order. Rural areas completely cut off. Remember COVID toilet paper hoarding? That was with functioning supply chains. Now imagine no supplies, no chains, and no toilets that flush. Society's veneer of civilization is about 3 missed meals thick. The transformer problem. Here's the real killer: large transformers. The transformer crisis. Modern grids need massive transformers, custom built for specific locations. Lead time, 12 to 24 months normally. Manufacturing requires electricity. Global production capacity, 100 per year. Number destroyed by Carrington Event? Thousands. These transformers weigh 400 tons, cost $10 million each, and are mostly manufactured in China and Germany. With no power grid to manufacture new ones, no ships to transport them, and no cranes to install them, how exactly do we replace them? Answer: we don't. We're screwed. The death toll. Congressional EMP Commission estimates for a year without power, 90% of U.S. population dead within 12 months. Causes: starvation, disease, violence, medical crises. Cities become uninhabitable within weeks, return to 1800s population levels. This isn't hyperbole. Without electricity, we can't grow, transport, or store food for 330 million Americans. We can't pump or purify water. We can't make medications. We can't heat homes in winter or cool them in summer. The carrying capacity of the U.S. without electricity is about 30 million people. Everyone else dies.
All right, we've covered the science. Now let's descend into the rabbit hole of Carrington Event conspiracy theories, because apparently a natural solar phenomenon that could end civilization isn't scary enough. People need to add government cover-ups and alien interventions. Conspiracy number 1. The government knows when it's coming. The theory: governments have secret satellites monitoring the sun and know exactly when the next Carrington event will occur, but aren't telling us to prevent panic. The evidence: classified solar observatories, underground bunkers for elites, mysterious military exercises, seed vaults in Norway, Denver International Airport, somehow always involved. Yes, the government that can't agree on a budget or fix potholes has secretly mastered predicting solar storms years in advance. They're just choosing not to share this information because reasons. Also, if they knew it was coming, wouldn't they maybe harden the grid instead of letting civilization collapse? Just a thought. Conspiracy number 2. HAARP can trigger solar storms. The theory: the High-Frequency Active Auroral Research Program, or HAARP, in Alaska can trigger solar flares and direct CMEs at specific targets. The logic: HAARP beams radio waves at the ionosphere. This somehow affects the sun, 93 million miles away. The government uses this for weather warfare. The 2012 near-miss was a failed attack on Iran. HAARP transmits 3.6 megawatts. The sun outputs 384.6 trillion watts. That's like trying to control a forest fire with a birthday candle from another continent while blindfolded. The physics doesn't work, the scale doesn't work, nothing works except people's imagination. Conspiracy number 3. The Carrington event was prophesized. The theory: ancient civilizations knew about solar storms and encoded warnings in pyramids, stone circles, and cave paintings. The evidence: Mayan calendar predicted 2012. It didn't. Egyptian hieroglyphics show solar storms. They don't. Stonehenge aligns with solar maximum dates. Nope. Nostradamus mentioned fire from the sky. He mentioned everything. Ancient civilizations that didn't have telescopes somehow knew about coronal mass ejections and geomagnetically induced currents. Sure, they were so advanced they encoded this knowledge in stone instead of, writing, "Hey, watch out for solar storms," in plain language. Conspiracy number 4. Time travelers prevented worse events. The theory: the reason we've dodged so many near misses is because time travelers keep adjusting Earth's orbit slightly to avoid CMEs. The timeline: 1859, they let it happen as a warning. 1921, reduced impact to prevent nuclear war. 1989, limited to Quebec as a test. 2012, moved Earth 9 days to avoid disaster. The next one, they might not save us. Time travelers with the technology to adjust planetary orbits are really invested in keeping our primitive civilization running. They're like cosmic helicopter parents, constantly saving us from our star. No, Earth, don't go that way, there's a CME coming. Conspiracy number 5. Carrington events are cover stories for EMP weapons. The theory? Governments use solar storms as cover stories for testing electromagnetic pulse weapons. The logic? EMPs and solar storms cause similar damage. Convenient excuse for infrastructure failures. No way to prove it wasn't natural. Perfect false flag operation. Yes, because secretly detonating nuclear weapons in space to create EMPs is much easier than just waiting for the sun to do it naturally. It's like faking rain in Seattle. Why would you bother? It's going to happen anyway. The kernel of truth. Here's what is true. Government preparations. FEMA has Carrington event response plans. Military has EMP-hardened facilities. Congress has held hearings on grid vulnerability. Some politicians have bunkers. Continuity of government plans exist. The conspiracy theorists are right about one thing. The government is preparing for this. Not because they're causing it, but because they know it's coming eventually and they want some semblance of governance to survive. The fact that they're preparing should terrify you more than any conspiracy theory.
Here's the most frustrating part of this entire story. We know how to protect ourselves from Carrington events. We have the technology. We have the knowledge. We just don't have the will or the money. It's like knowing a hurricane is coming and choosing not to board up the windows because plywood is expensive. Solution number 1, harden the grid. What we need? Faraday cages around critical transformers, GIC blocking devices on transmission lines, backup transformers and storage, rapid disconnect systems, and grounding resistors. Cost? $20 to $30 billion for the US grid. What we're actually doing? Almost nothing. Congress spent $1.7 trillion on the F-35 fighter program. For 1.5% of that cost, we could protect the entire power grid from solar storms. But no, we need planes to fight enemies that might not exist while ignoring the star that definitely wants to kill us. Solution number 2, better space weather monitoring. What we need? Satellites at the L1 Lagrange point, solar observatories monitoring 24/7, AI prediction systems, international warning networks, and public alert systems. Current status? We have some monitoring, it's underfunded, international cooperation is poor, and public awareness is near zero. We can track every hurricane from formation to landfall, but we're basically guessing about solar storms until they're hours away. It's like having smoke detectors that only work after the house is fully engulfed. Solution number 3, distributed renewable energy. A distributed grid with local renewable energy would be naturally resistant to Carrington events. Why it works? Shorter transmission lines means less induced current. Local generation means isolated failures. Microgrids can disconnect and operate independently. Solar panels and wind turbines are less vulnerable than transformers. Battery storage provides backup. Why we're not doing it? Utility companies like centralized control. Initial costs are high. Political resistance to renewable energy. And it's always worked this way mentality. A distributed renewable grid would not only resist solar storms, but also cyber attacks, physical attacks, and regular storms. But apparently, we'd rather have a vulnerable centralized grid because change is scary and oil companies need profits. Solution number 4, global cooperation. Solar storms don't respect borders. The response needs to be global. What's needed? International Space Weather Treaty, shared monitoring data, coordinated response protocols, a global strategic transformer reserve, and cross-border power sharing agreements. What actually exists? Some academic cooperation, limited data sharing, no formal treaties, and every nation for itself mentality. We cooperated to eradicate smallpox. We cooperated to fix the ozone hole. But cooperating to prevent technological collapse? Nah, too complicated. Let's just hope the sun hits someone else first.
Solution number 5, personal preparation. Since governments won't protect us, here's what individuals can do. Basic preparation. Emergency water, 1 gallon per person per day for 2 weeks minimum. Non-perishable food, 1 month minimum. Medications, 90-day supply. Battery-powered radio. Cash, ATMs won't work. First aid supplies, backup power, generator or solar. Advanced preparation. Faraday cage for electronics. Ham radio license and equipment. Water purification system. Alternative heating or cooling. Security measures, and community mutual aid network. Congratulations, you're now a prepper. Not because you're paranoid, but because your government would rather spend money on literally anything else than protecting the power grid from the star that definitely wants to attack it. The economic insanity. Cost of protection, $20 to $30 billion. Cost of Carrington Event, $1 to $2 trillion in the first year alone. Return on investment? 40 to 100 times. Political will? 0. We're essentially playing Russian roulette with civilization to save money that's less than Americans spend on pizza every year. We spend $50 billion annually on pet food, but can't spend half that to prevent societal collapse. Our priorities are somewhat skewed.
The Carrington Event wasn't the first time the sun tried to kill Earth. It was just the first time we had technology to notice. By studying ice cores, tree rings, and historical records, we found evidence of solar attacks throughout history. Most of them make Carrington look like a gentle slap. The Miyake events, when Carrington looks cute. 774 to 775 AD, the Charlemagne event. The strongest solar event in recorded history happened while Charlemagne was conquering Europe. The evidence, carbon-14 spike in tree rings globally, 10 to 20 times stronger than Carrington, lasted multiple months possibly, Anglo-Saxon chronicle, red crucifix in the heavens, Chinese records said thundering sounds from a blue sky. This event was so powerful, it changed the radiocarbon content of Earth's atmosphere. If it happened today, it wouldn't just destroy the power grid, it would destroy everything electronic. Every computer, every car, every medical device. We'd go from information age to Stone Age in minutes. 993 to 994 AD, the Forgotten Apocalypse. Another Miyake event that nobody talks about. What happened? Another massive carbon-14 spike, possibly stronger than 774 AD. 0 historical records, suspicious. Coincides with societal disruptions globally. May have triggered Viking expansion. Isn't it weird that we have no written records from 993 to 994? Almost like something happened that disrupted civilization globally. But I'm sure it's just a coincidence that multiple societies experienced upheaval at the exact time the sun had another temper tantrum. The Aboriginal Australian records. Aboriginal Australian cultures have oral histories going back 10,000 plus years. They describe multiple times when the sky burned. The stories tell of sky serpents of fire, or aurora australis, days when the sky bled, red aurora, nights bright as day, extreme aurora, times when the spirits fought in the sky, geomagnetic storms, periods when the seasons went wrong, climate disruption. These aren't myths, they're observations, 10,000 years of watching the sky and passing down warnings. We've had modern astronomy for 400 years and we're already ignoring the warnings. 1770, Captain Cook's light show. September 16, 1770, Captain Cook is sailing near Australia when... Cook's log. The phenomenon was remarkable. The southern lights were so bright that shadows were cast on the deck. The sailors were frightened, believing it to be an omen. The compass spun uselessly. What actually happened was a major geomagnetic storm. Aurora australis visible at 30 degrees latitude, lasted 3 days, no technology to damage, considered a curiosity. Cook thought it was beautiful, a natural wonder. If the same storm happened today, his GPS would fail, his radio would die, and his electronic navigation would have a seizure.
Beauty is in the eye of the pre-electronic beholder. 1582, the fire that wasn't. March 8, 1582, across Europe and Asia. Contemporary accounts: the northern sky was aflame. Fire fell from heaven, but nothing burned. The sky bled for 3 nights. Birds sang at midnight. Iron tools became too hot to touch. What this was? A massive geomagnetic storm. Aurora visible in India. Induced currents even without technology. Heated metal objects. Confused biological rhythms. Metal tools became hot to touch from induced currents in 1582, before electricity. The Earth itself became an induction coil. Imagine what that would do to our metal-wrapped, wire-covered modern world. The Chinese chronicles 2,000 years of solar violence. Chinese astronomers recorded everything. Their chronicles show solar storm frequency, major events every 50 to 100 years, extreme events every 200 to 500 years, civilization-threatening events every 1,000 to 2,000 years, pattern acceleration during solar grand maxima, pattern reduction during grand minima, like the Maunder minimum. According to Chinese records, we're overdue for an extreme event. The last civilization-threatening solar storm was 774 AD. That's 1,250 years ago. We're playing cosmic roulette, and the chamber is getting full.
Let's zoom out and think about what the Carrington Event really means, not just for our power grid, but for our species, our civilization, and our future. The complexity trap. Every advancement makes us more vulnerable. The progression. 1800, solar storm, pretty lights. 1859, solar storm. Telegraph fires. 1921, solar storm. Some infrastructure damage. 1989, solar storm. Regional blackouts. 2024, solar storm. Potential civilizational collapse. 2050, solar storm. Question mark, question mark, question mark. We're like a gambling addict doubling down after every win. Each technological advancement raises the stakes. We've bet civilization on the sun's good behavior, and the sun doesn't even know we exist. The Carrington filter. What if this is why we don't see alien civilizations? The Great Filter Hypothesis. Life develops, intelligence evolves, technology advances, electronics become essential, civilization becomes vulnerable, star has a tantrum, back to Stone Age, repeat until extinction or stellar death. Maybe every civilization eventually builds a technological house of cards just as their star decides to blow. It's cosmic irony. You need technology to protect yourself from stellar storms, but that same technology makes you vulnerable to them. The reset button theory. What if solar storms are civilization's reset button? The cycle. Civilization develops, grows complex and interconnected, becomes dependent on fragile systems, solar storm hits, collapse and reset, survivors rebuild, knowledge is lost, myths remain, cycle repeats. Maybe Atlantis wasn't destroyed by water, maybe it was destroyed by plasma. Maybe every advanced ancient civilization we can't explain was reset by their star. We see ruins and assume primitive builders, but what if they're the remnants of post-solar storm survivors? The dependency paradox. We know we're vulnerable, but can't reduce our dependency. Can't go back because 8 billion people require industrial agriculture. Cities require massive infrastructure. Medicine requires refrigeration and manufacturing. Communication requires electronics. Economy requires computers. Everything requires electricity. We're addicted to electricity like a junkie to heroin. We know it makes us vulnerable. We know the next hit could kill us, but withdrawal means certain death for billions. So we keep mainlining electrons and hoping the sun doesn't notice. The preparation paradox. Individual preparation is rational, but collectively insufficient. The problem: if everyone prepares, society acknowledges the threat. If society acknowledges, we'd have to actually fix it. Fixing it is expensive, nobody wants to pay, so we pretend it's not a problem. Most don't prepare. Those who prepare are mocked. Preppers are crazy. When it happens, the prepared can't save the unprepared. It's a perfect trap. Those who see the danger are labeled paranoid. Those who ignore it are normal. Society rewards ignorance and punishes prudence. We've created a system where rational preparation is irrational behavior. The cosmic perspective. In the grand scheme, solar storms might be good for life. The argument: prevents any one species from dominating too long, forces evolutionary adaptation, maintains planetary habitability, prevents technological stagnation, creates selection pressure for resilience. Maybe solar storms are Earth's way of preventing any one species from getting too comfortable, like a cosmic gardener pruning back overgrowth. We're not special, we're just the current experiment in consciousness. If we fail the solar storm test, something else gets a turn. The choice. We have 3 options. Option 1, prepare. Harden infrastructure, build resilience, accept the cost, survive the next event. Option 2, ignore. Hope we get lucky. Keep gambling. Eventual collapse, civilization ends. Option 3, transcend. Become multiplanetary, build redundant civilizations, spread the risk, ensure species survival. We're at a crossroads. We can either prepare for the inevitable, ignore it and hope, or transcend the problem entirely. But choosing nothing is choosing option 2 by default, and the sun doesn't care about our indecision. So here we are, minutes into understanding how a star 93 million miles away could end everything we've built in an afternoon. The Carrington Event wasn't a warning from the past, it was a preview of the future. What we've learned: the sun regularly tries to destroy technological civilizations. It's not personal, it's just physics. We happened to develop electronics during a relatively quiet period, built our entire civilization on them, and now we're hoping the quiet continues. Hope is not a strategy. The brutal truth. The facts. Another Carrington Event is 100% certain. Could happen tomorrow or in 100 years. We're not prepared. Most people don't know or care. Governments are doing minimum. The cost of prevention, less than a cost of pizza. The cost of failure equals civilization. We're playing Russian roulette with 6 bullets in 6 chambers. The only question is when we pull the trigger, not if it fires. Every day the sun doesn't kill our technology is a gift, a borrowed day, a stay of execution. What you can do. Today, learn about space weather. Start basic preparation, spread awareness, contact representatives, support grid hardening initiatives. This month, build emergency supplies, learn analog skills, create community networks, reduce electronic dependency where possible. This year, advocate for infrastructure protection, support renewable distributed energy, prepare for extended blackouts. Hope you're not too late. The Carrington Event of 1859 burned telegraph wires and painted the sky. It was beautiful, terrifying, and manageable. The next Carrington Event will burn transformers and paint civilization's end. It will be terrifying, catastrophic, and preventable, if we act. Richard Carrington saw the sun attack Earth on September 1, 1859. He warned us. He showed us what the sun could do. We built a civilization entirely vulnerable to exactly what he witnessed. Tonight, when you turn on your lights, charge your phone, use your computer, remember that you're living in the brief window between solar storms, a window that could close tonight, or tomorrow, or next week. We don't know when. We only know it will. The sun doesn't care about your plans, your technology, or your civilization. It's been exploding for 4.6 billion years. It'll keep exploding for another 5 billion. We're just a temporary arrangement of atoms that happen to develop electronics at the wrong time. Or maybe the right time. Maybe we're the first civilization in Earth's history capable of understanding and preventing our own electromagnetic apocalypse. Maybe this is our test, our filter, our moment to prove that intelligence can overcome cosmic indifference. The Carrington Event isn't history, it's prophecy. It's a promise from the sun that we'll try again, and again, and again, until we either prepare for it or succumb to it. The telegraph wires that burned in 1859 were a warning. The question is, will we listen before the next warning becomes a eulogy? Current solar status, active. Time since last X-class flare, time until next Carrington event, unknown. Your preparation level, the sun is watching. Well, not watching, it doesn't have eyes, but it's there, always there, waiting to remind us that we're not as advanced as we think. Sleep tight,